do a problem in limits using differentiation. So the problem is, find the limit of x tending to 2 of square root of 1 minus cos 2 of x minus 2 divided by x minus 2. So the four options given are as follows. So when you look at this, you obviously cannot apply x equal to 2, because if you do that, then you're going to end up with a 0 by 0 situation. And that is good, because then we can apply the L'Hospital's rule. So we'll come to that. Before that, we see that it is square root of 1 minus cos 2 theta. So here is where we use our knowledge of trigonometry, and we say that 1 minus cos 2 theta is cos square theta minus sin square theta, and it can be written as 1 minus 2 sin square theta. So which means that 1 minus cos 2 theta will be 2 sin square theta. And that means that we can eliminate the square root. So let's get to the solution. So that's exactly what we just did. We used 1 minus cos 2 theta equal to 2 sin square theta. And for folks who are not aware of this, immediately you can start from cos 2 theta as cos square theta minus sin square theta. And then you can expand it, and you will see that cos square theta is 1 minus sin square theta. So that makes it 1 minus 2 sin square theta. And so you switch the places and you'll get 1 minus cos 2 theta equal to 2 sin square theta. So once you apply it in this problem, you will see that the square root gets eliminated, because square root 2, and you get a mod of sin x minus 2 divided by x minus 2. And you have to be careful here that the modulus is very important for this problem, and that's the main trick in this problem, because when you take a square root with respect to limits, you have to consider both the signs. So here on, if you take the left hand limit, which is basically that you consider the negative of the sign of x minus 2, and you apply L'Hospital's rule now, which is basically that the limit is of the form 0 by 0. So you're going to differentiate, and then you apply it. The bottom becomes just 1. So you end up with just of cos of x minus 2, and that is just minus square root of 2. And when you go to the right hand limit, you're going to end up the same way, but you're going to end up with square root of 2. So the trick here is that the left hand limit and the right hand limit are not the same. That is exactly why the answer is that the limits do not exist. So the answer is D here.